Hi everyone, my name is Jyotsnarani Tripathy. I am working as an assistant professor in Department of IT in VNR, VJIT Hyderabad. So today I am going to explain about one algorithm of data mining, where I can explain about the complete numerical which is using the association rule mining, and within that candidate generation, how we generate the candidate and how the pruning operations, and how we calculate the evaluation by using the confidence. We discuss about all these things. So next, before going depth to about all the a priori algorithm, first the basic we know that what do you mean of that. It is where we uncover frequent item sets and association rule of different transactions. Suppose we are going to market and we purchase something, suppose bread, butter, milk. Okay, so in our means that particular sales, they can here collect different datas, and according to our transaction they are creating different transaction sets. So from that transaction sets, how we find out that what are that transactions are frequent transactions. So by using that algorithm, a priori algorithm, we solve here. So actually this algorithm is operated on a bottom up approach, and how these are going on, I will explain one by one all the steps. So for this algorithm, basically we are using certain formulas and certain key terminologies are there. So from the starting to the end, we are using support and confidence. These words are more frequently. So for that support, how we calculate the support. So the formula for the support is support A equal to count A divided by total transaction. So what does it mean? Suppose one transaction, I just give one example here. Now the next I give that example and explain all the details about that example. Suppose this is another example. So there here transactions are T100 to T900. So there are in one transactions T100, I1, I2, I5 are three items. So next transaction I2, I4, then another two transactions. Then T300 another transaction with that items I2 and I3 like that. So how many means items? Suppose I1 is in transaction 100 is there, then next in transaction 400 is there, then next in transaction 500 is there. So what does the support mean? How we calculate it? Here, according to the formula here, support A means it is a item 1. Here the item 1 is, suppose if we are taking the item is I1. So how we calculate is I1 is here, support I1 equal to count of the I1 divided by total transactions. So here how many transactions are there? T100 is 1, T200 is another. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 909 transactions are there. So here also I am written that n equal to 9. So how we calculate this? Support A, which is a I1. So we count that I1 how many times divided by total number of transactions. Means suppose it is 9. So if the count equal to 6, so 6 divided by 9 is the support we count here. Next, for confidence, then how we calculate the confidence? We represent the confidence is here A tends to B, which equal to support A union B divided by support A. And in the next means whenever we are calculating the confidence, we are calculating the confidence A tends to B as well as the B tends to A. So what is the difference between A tends to B and B tends to A? That here the support is written as support A union B divided by support A for A tends to B confidence. But whenever we calculating B tends to A, so the same formula is once again we change that support A union B divided by support B. Why so? Because A union B is the same answer like that of B union A. So we are writing the formula once again, support A union B divided by support B for the calculation of B tends to A confidence. So in that right side here one is your shipping basket, that shopping basket, what are the haphazardly we are seeing. And next, after the recommendation, what after that calculation, what the shopping basket is recommend for you. Suppose one person is purchasing milk, then that person, if we recommend them for bread or not. Okay, so we calculate in this means algorithm all these support and confidence, and we find out one association rule for this. And what is the strong rule here we calculate means we have to find out one recommendation here, how we that one supermarket give the recommend for the shopping next. So before going to that one problem, so first we have to analysis that what are the problem statements are there, what are the data sets are given. Okay, so previous slide I show you that what are the means basic terminologies we are using here, and next here I am explaining about what is the problem statement and what are the data sets we are taking. So here in the right side you see that here 10 means 9 data sets, we are 9 transactions we are taking, and these are transactions all it can show here how many items we are purchasing. Okay, so the first transaction T100, there are 3 items, I1, I2, I5. Second T200, there is 2 transactions, I2 and I4. So here repeatedly we are using the words as item, item set. Okay, so what do you mean by item and item set? Here I1 is a single item. Okay, and if we combine this I1, I2 and I5, this is called as the item set. It is a combination of more than one items. Like that here the second transaction, this is also a combination of more than one item. It is a item set which is I2 and I4. Okay, in the left side we are first analysis about what are in that question, what are the problem statement here. So there are 9 transactions are given. Okay, and in that question it is given that minimum support count which is equal to 2. Okay, so support we are counting that one in one transactions, suppose I1, I2 and I5 are there. So among these 9 transactions, how many I1s are there? And from that I1 we are calculating here minimum support count which is given in the question 2, which is 22.2%, and the minimum confidence is given which is 60%. So our goal is here what? Find all the item sets and find out or generate the proper strong association rule by using this a priori algorithm. Okay, so next what should we do? What is our first step? So the first step is frequent one item sets. Okay, so in the total item sets, where that particular one is the single item, so I1 is the one, so how many times that one item is present in total all the transaction by combining all the transactions. So how many transactions are there? 9 transactions are there. So from this we have to calculate the frequent one item set, which we say here it is L1. Okay, so we are here calculating one candidate set C1, where we are writing in one column we are writing the item sets, and in the next column we are writing all the support count. So what do you mean by the support count? So here we are counting by using our all the total that formula. So the formula, what is the formula? So how many times it occur? So I1 is occur how many times? Then divided by the total number of transactions. So the total number of transaction is 9. Okay, so here we count and we are find out that if that transaction is more than that 2 or not. 2 is the minimum support is given. So it is more than 2 or not, we count it. And here we find out that all are more than 2 and it is equal to 2. So we consider the equal to, because it is written that minimum equal to 2 or more than it 2 it can take. Okay, so the here we write all that pass. That means all the items are here passed for that one item set. All are passed to the minimum support 2. Next, in the step 2, what we calculate? We are calculating the candidate 2 item set, which we call it as C2, and here we are using that joining operations C2 equal to L1 join L2, which can generate a combination of more than items there. So how we generate? Here written I1 I2 I1 I3. So how we generate? Just go back to the previous slide. So here first we consider about the I1. So I1 is combining with I2, I1 is combined with I3, I1 is combined with I4, I1 is combined with I5. Like this one set we are preparing. First I1 is I2, I1 is I3, I1 is I4 and I1 with I5. Next, what should we do? Once again we do the same operation. I2 is once again with I3, I2 is once again with I4, I2 is once again with I5. So like this we are once again here write I2 to I3, I2 to I4, I2 to I5. Like this we combine here I3 to I4, I3 to I5 and I4 to I5. So these are the combinations of all these where two item sets we are combine it. Okay, so all these are the set. We have to once again calculate whenever the combined sets are there, if they are here fulfill that same support or not. Okay, so how we calculate this? Here the pruning operation, that right side it is written that the pruning operation, that means from the first here L1 we are not discard any items there. Why? Because all are more than 2. Here we once again calculate that if they are more than 2 or not. If that more than 2 is there present equal to or more than 2, then we take it. Otherwise we are making that pruning operation and we here not taking some item sets which are not fulfill the criteria of that. Okay, so next scan and compute once again support count of each pair of C2. Okay, so what are the pair here? I1, I2 to up to I4, I5 are the pairs, and where we calculate and we once again count the support. Next. So how we count the support? Already we know the formula. So I1, I2 is how many times in a particular means total data set. So once again we go back to the previous slide. Here the main data sets are there. So here look, I1, I2 is here present. Okay, I1, I2 is here present. Then I1, I2 is here present. I1, I2 is here present. So I have to scan the total data sets. How many times the I1, I2 is present there. Okay, so there I calculated how many times? It's 4 times. So we compare it. 4 is greater than equal to 2 or not? Okay, if it is greater than 2, that means we consider this for the next iteration. Okay, so next we are considering for the next I1, I3. I once again means calculated that I1, I3 equal to 4 or not. So for that we go back to the previous slide. Look this previous slide, I1, I3. So here I1, I3 is first transaction not there, second transaction not there, third transaction is also not there. But in this fifth where T500 is written, there I1, I3 is here. Here next in the T700, this is also I1, I3 is here. Here one I1 is here, one I3 is here. Here another I1 is here, another I3 is here. So how many times? It's also 4 times. So what we are doing here? I1, I3. So the support count we are find out the combinations are 4 times here. So the combination if it is 4 times here, it is greater than equal to 2. So once again, we consider this case as yes. So like that, we are given here how many combinations and we are find out the support count for all. So suppose I am taking another example I1, I4, which is here written 1 only. So once again we go back to the previous slide. So I1, I4, here it is not there, here it is not there, here it is not there, here it is I1 and I4 are there. Okay, rest if we scan from this starting to this and this and this, so I1, I4 is not present in any transactions. So what should we do? We go back once again to that same slide, and here we write here I1 and I4 equal to 1. So whenever it is 1, once again we calculate 1 divided by total number of 9 transactions. So it is here, if we the formula we calculate, or whatever be the minimum support is given, we calculating this and we find out that here it is 1 is less than that of 2. So what should we do next? Whatever be that here given as greater than of that support count 2, so we are find out that and we taking this as a frequent item set. So how many S are here? Here I1, I2 one S, I1, I3 another S, and like that we are taking here these are 4 and these are 2. Next, we discard those who are support count is not more than that 2. Next. So this is all about the 2 item sets. Here we are calculating for 3 item sets. Okay. So how we are calculating for 3 item sets? Look, these subsets are I1, I2, I1, I3, then I2, I3, those who are belong to L2, and here I1, I2, I1, I5, I2, I5, it's also belong to another L2. Okay, so from this total we are find out here I1, I2, I3, which are the frequent sets where the combination of, look, I1, I2 and I1, I3. So here the common is here I1 for both these. So we are taking I1, I2, I3. Next for I1, I3 and I2, I3. So the common is I1 there. So I1, I2, I3 we are taking. Okay. So for I1, I2 and I2, I3, the common here also I1, I2, I3. So if we are taking any combinations, then we are find out that I1, I2, I3 is there. For the next, if we combine these threes and we are getting that I1, I2, I5 are the next combinations. So we join the these two means sets, and we find out, we calculate it that it is a valid operation. So why? Because it is greater than I1, I2, I3 is greater than 2 or not. We calculate it and we find out that it is also a valid operations. So next, how we count it is a valid operation? So the same procedure once again we follow. Here we are writing it is a valid operation, but how we count it is a valid operations? That means we do the same operations here. So here these I1, I2, I3 combinations, we are find out the support count is 2, which is here greater than equal to 2. So the same thing here we follow for the starting to the end, and we calculate that here this means if it is greater than 2 only, we are consider these as a means frequent sets, which are frequent. Okay, so the algorithm now it's a terminate for the L4, which is a 4 item set. Why? Because 4 item set, if we are taking a combination from these I1, I2, I3, I4, I5, like this, if we combine it, then this type of combinations are not available in that data sets. Okay, so whatever we are doing here, we are terminating our algorithm here to stop our algorithm, because if we not stop, we have some logic that we stop our algorithm there. Okay, so here we stop our algorithm whenever the candidates are C4 only. Okay, next, what we understood, what are the things here, what are the rule of generating these all these things? So extract subsets, calculate the confidence and filter a strong rule. Okay, so then next how we calculate the confidence here. So what is the confidence calculation formula? So and how many sets we are here calculating the confidence here. So next we are here calculating the confidence of I1, I2, I5, and next like another combination is there, which is I1, I2, I3 also. Okay, so how we calculate this? It is support of I1, I2, I5. Here three things are given. That means we are calculating means our formula is support of A union B divided by support of A. Okay, so suppose here we are taking three items are there. Suppose we are taking here three items. So what should we do? First I1 and I2 we are taking, and that I1 and I2 we are taking as a first A. Okay, and I5 is second, which is B. Okay, so I1, I2, support of I1 union I2, then divided by, here union means I1, I2 we are taking 1, union, then support of I5. Okay, so I1, I2 we are taking as 1, then I5 we are taking as B. It is I1, I2 is A and I5 equal to B. So support of A means support of I1, I2, then union support of I5. Okay, divided by support of I1 and I2. Okay, so what is the result here? It equal to 2 divided by 4. Okay, so how you calculate I1, I2? What is the support here combinedly? We go back once again. Okay, so what is the support here? I1, I2 and I5. Here it is 2 because it is a combination of I1, I2 union I5. But what about that I1 and I2 here? I1 and I2 is here 4. Okay, so how we calculate it? Look once again the confidence formula. So there we calculate here 2 by 4. Okay, so the first line you just look at the first line. It is the support of I1, I2, I5 divided by support of I1 and I2. What I said previously, that we are calculating the confidence as confidence of A tends to be equal to the answer is support of A union B divided by support of A. So here what is the A value here? Here we are taking I1, I2 as A and I5 as a B. So support of I1, I2 union I5, which is our previous answer I already shown to you, which is 2, and support of I1 and I2, which is equal to 4. So 2 divided 4, which is a 50%, which is not our minimum confidence. Okay, so our minimum confidence is given equal to 60%. So that's why it is written as discarded. So next, once again we calculate of next support I1, I2, I5 divided by support I1 and I5. So why I am taking here I1, I5? Here I am taking the combination of that I1, I5 as A, and next here one value, suppose I1, I2 is A, and divided by A divided by, if it is A tends to B, so divided by support of A. So here it is taken as A as I1 and I5 tends to, what is the value here? It is written as 1,5 is taken as the base value. Okay, and the top is here taken as a support of combination of all. Okay, that means here B is A is taken as a 1 and 5, and next A union B is taken as a 1, 2 and 5. Okay, so the final value is support of 1 and 5 is combinedly taken as a 2, and support of 1 to 5 which is already written in the previous front, which is 2. So 2 divided 2 equal to 100%. Next, once again the same 1 to 5. Look here, the combinations we are writing. Here the combinations of first we are taking, because A union B is same as the B union A. So we are writing the same thing, support 1 to 5 repeatedly. We are not writing that same 1, comma 5, comma 2. We are not right, because 1 to 5 is same as 1, 5, 2 and 1, 2, 5 and 5 to 1, like this it is same. So we are taking here support of 1 to 5 divided by, here we are taking 2 and 5, which is the next another A we are taking. Okay, either it is A tends to B or it is B tends to A. So 2 divided by 2, which is also a strong rule. Like the same, okay, we are taking here I1 to I2 and I5. Okay, so above we are taking first I1, I2 tends to I5. Okay, next we are taking I1, I5 tends to I2. Okay, next we are taking I2, I5 tends to I1. Then next we are taking another combination I1, I2, I5 divided by support of I1 opposite. Okay, so here I1 is 1 and I2, I5 are other. Okay, so this type of combination if we are taking, then next we are discarding this. Why? Because the value is 33%. Like this we are calculating the next one, which value is 28.5%, which is discarded. Next we are taking another, which is 2 divided by 2, which is 100%, and we are taking that rule. So here it is not mandatory that we are taking all the rules which are 100%, but that is, it is minimum support is 2, because we are doing the pruning operations. So minimum support is 2, and minimum confidence here we are taking either equal to or more than 60%. So it is given in the question. So how we are means what is the value if we take? If we take the value means we change it, then the means rules are also changed. If we are taking the confidence less, then the discard or that support less, then the discard persons are also less here. Thank you.